Hi, welcome to our math. Today I'm doing a series of videos on an exam review for an exam I gave several years ago in a math class I give that's on linears, matrices, and linear programming. This particular page of the exam is mostly on linears, matrices, and graphing inequalities. I realize I've been saying it's a 5-page exam. I think I added a 6th page, so it might be 6 videos. Anyways, that is not the problem for page 3. A fundraising group is selling cookies and cupcakes. They sell cookies for $2 and cupcakes for $7 each. At the end of the event, they have sold 340 desserts for $1,755. Set up the system of equations for this situation. First of all, we need to define our variables. I like logical variables, but since cookies and cupcakes are both C's, if I said C and C, it would not be at all helpful. I could say K and P or say K and C, but I'm just going to use X and Y. I'm going to say X is cookies and Y is cupcakes. And since I am using X and Y, it is really, really important to define my variables because otherwise at the end, I'll have no idea what is what. So I'm going to say the total is 340. So X plus Y equals 340. And then cookies are $2 each, so 2X. And cupcakes are 7, so plus 7Y is equal to $1,755. And this is my system. Now it says convert the system into a matrix using this form. So normally we use an augmented, which is 1, 1, 340, 2, 7, 1750, and 1 matrix with a line for the equal sign. That's an augmented matrix. That is not what this is asking for. It is asking for an A matrix, which is the coefficients, an X matrix, which is the variables, an equal sign, and an answer matrix. So this wants specifically 1, 1, 2, 7, XY equals 340, 1755. That's what this is asking for, that matrix. Okay, next it says calculate the inverse of the coefficient matrix. Well, the coefficient is a fancy word for number multiplied to variable. So an inverse is calculated by taking the coefficients, augmenting your matrix, and putting an identity matrix on the other side, and then doing exactly what we did when you do Gauss-Jordan elimination. So for Gauss-Jordan elimination, we are going to ignore everything except for that first column. We only care about that first column. And for our first step, we're going to pivot on this 1. And what we are caring about is zeros. And so what we want is we want to zero everything out of the numbers we can see. So that column, we want to zero everything out in that column using the number I've circled. So this first row is going to stay exactly as is. And we're going to say 2 times row 1 minus row 2. Because if we take 2 times 1, it becomes 2. And 2 minus 2 is 0. We only focus on this column. We ignore everything else about the matrix. We are just using this column and zeroing out everything except what I've circled. That's it. That's what we're doing. Okay, now we uncover because we have to affect all of the other rows. So row 1 is going to stay as is. 2 times row 1 is 2, 2, 2, 0. Minus row 2 is going to be negative 2 minus 7, 0 minus 1. We get a 0, a minus 5, a 2, a minus 1. And I'm going to rewrite this all right here. So the first row didn't change, 1, 1, 1, 0. The second row becomes, this is going into row 2. 0, negative 5, 2, negative 1. So again, we're trying to make this into an identity matrix, and this becomes our inverse over here. We are almost there, but not quite. So what I'm going to do now is I am going to cover this side up because what we want to do is focus on that second column. And we are going to pivot on, we pivoted on the first row, first column. Now we're going to pivot on the second row, second column. Notice I'm not dividing to make a 1. It doesn't matter. We have calculators. We can figure out numbers that aren't ones. We don't care about the ones. We care about the zeros. We can get ones later. We can divide later to get our ones. We care about getting zeros. Focus on your zeros. We can get our ones later. So if I want to get this to be a 0, I'm going to do 5 times row 1 plus row 2. I'm going to add this time because the signs are different. I subtracted here because the signs were the same. Now, I do want this to be an identity matrix, 1, 0, 0, 1. So to save myself from writing as many matrices as are possible, I am going to end up saying row 2 divided by -5 here, because there isn't a third row. This next matrix I write is going to be the last one. So because it's the very last time I write a matrix, I will end up dividing by 5 here. Otherwise, I usually don't affect my pivot row. It's only because it's the last time I'm pivoting. Okay, so let's see how all of this comes out. Ooh, actually, how far down can I go now that I've messed everything up? So, I want this still seen. Okay, so 5 times row 1 is 5, 5, 5, 0. Row 2 is 0, -5, 2, -1. I get 5, 3, 7, negative. That's a 0. Where did I get 3? 5. I don't know. I think I was looking up here. 5, 0, 7, -1. Okay. I want this to be a 1. I want this to be 1, 0, 0, 1. So I'm going to divide this by 5 before I write up my last matrix. And I'm going to get 1, 0, 7/5, -1/5. And when I bring this over, I'm going to get 0, 1, because I'm dividing by -5, -2/5, 1/5. So my inverse matrix is 7/5, -1/5, -2/5, 1/5. Okay, so then the very last question says, solve the system any way you want. Now, we just did all this work finding this inverse matrix. Let's not use it. There's all those fractions. Why? This is such an easy matrix to use, or it's an easy system to use. I'm going to take this top line, x plus y equals 340. So x plus y equals 340. And I'm going to see this 2 right here. And I'm going to multiply both of these by -2. And I'm going to get -2x minus 2y equals -680. That's just going to be my first step. And then I'm going to bring this second line, this 2x plus 7y equals 1755. And I'm going to write it down here, 2x plus 7y equals 1755. So I just transpose that down there. And yeah, that's what I'm going to do. This is what I'm solving. When I add down with elimination, I'm going to get a 5y equals 1075. And I'm going to divide by 5. And I'm going to get that y is equal to 215. Then I'm going to use the original, x plus y equals 340. X plus 215 equals 340. Subtract the 215 over, and I'm going to get x is equal to 125. Then I'm going to check. I'm a big advocate of checking things. So is 2 times 125 plus 7 times 215 really equal to 1755? 1755. It is. It says, right, leave your answer in a sentence. So they sold, let's see, the 215 that I originally wrote, y is equal to cupcakes. Y is cupcakes. So they sold 215 cupcakes and 125 cookies. Sentences do not need to be creative or complicated. There we go. So this is the problem. Yes, I found this matrix. I'm not going to use it for several reasons. One, what if the math is wrong? Two, why do more matrix multiplication when this is just as easy? All right. The last question on this page is graphing. This is deceptive. Graphing lines does not need to be hard, but there are a lot of points wrapped up into this. It says graph the following inequalities. Okay, so let's start with that. Just graph the system of inequalities. There's lots of words after that. Okay, so if I take 3x plus 5y, and I'm going to change this to equals 15. I'm going to do this thing called, and this is my favorite thing ever, called the cover it up method. If I cover up the 3x and I have 5y equals 15, and I divide by 5, y equals 3. If I cover up the 5y and 3x equals 15, then x is equal to 5. 1, 2, 3, 4, 5. Because I'm looking for intersection points, let's see. 3/5, 1, 2, 3, 4, 5, 1, 2, 3. All right, so I have 3 points. The equal sign right here means the line is solid. So I'm gonna bring in my handy dandy ruler, graph a solid line that goes well beyond, and there. Now, I'm going to test a point. I'm going to test the origin. It's the easiest. Is 0 less than or equal to 15? No. So I don't go towards the origin. I'm going to go away. So this is the side. I'm going to shade this line. Perfect. Okay, next. I'm going to look at, so just to kind of give you what I did, when I covered up the y, I had 3x equals 15, so I graphed x equals 5, and I graphed y equals 3. All right. For the next line, I have 6x minus 8y. I'm going to do equals negative 24. All right. If I, again, cover up the x, and I have 8y equals negative 24, if I divide, I have y equals 3. Hey, that's the same point. And if I cover up the negative 8y, I have 6x equals negative 24. If I divide by 6, I have x equals negative 4. X equals negative 4. 1, 2, 3, 4. Let's see, 3, 4. 1, 2, 3, 1, 2, 3, 4. Now I have a couple of points there. So this one is dashed. So I'm going to dash that one. Again, I'm going to test, is 0 less than negative 24? Again, that's a false. So I'm not going to go towards the origin. I'm going to go away. Okay, not bad. And the last line is y is greater than 6. Well, y is 6. 3, 4, 5. So this is right by where this graph is kind of messed up. One variable lines are either horizontal or vertical. If I'm at y equals 6, I'm going to plot the point and cross. So I'm going to cross here. Because of that equal sign, it's a solid line. Here's where you have to be very, very careful because your instinct is to just shade in that little triangle right there. But it's greater than. So is 0 greater than 6? No. So I'm not going down. I'm going up, which means I'm shading this like little boat looking area, which means when it says, all right, so that's graphing the inequalities. State the points of intersection. That's this point right here, which is at 4, 6. And let's see, 1, 2, 3, 4, 5, negative 5, 6. All right. And then it says determine if the feasible region is bounded or unbounded. Because this is going forever up, there's nothing stopping it. It is unbounded. Ah, So you got to be careful. So if we do this next one a little faster, I'm going to not write as much because now you see what I'm doing. And you know, we are already at 15 minutes on this page. If I cover up the 8x, y is at 8. 1, 2, 3, 4, 5, 6, 7, 8. If I cover up the y, x is at -4. 1, 2, 3, 4. And this is, so this is not an equal sign, so it's dashed. So dash away, dash away. If my test is 0 less than -32, the answer to that is no. So again, I'm going to do that. For our next line, if I cover up the x, y, positive y, 30, y is at 3. If I cover up the y, 30 divided by 5 is 6. 1, 2, 3, 4, 5, 6. I can see that my slope here, there's our point right there. All right, so this one is with the equal sign solid. So I'm going to make this one solid. Notice I'm putting arrows at the end of every line. There's all these little pieces. Is 0 less than or equal to 3? Hey, this one's true. I go towards their origin. One of them had to be true eventually. And then here we have x is -6. 1, 2, 3, 4, 5, 6. Plot the point, cross the line. This one is also equal. So we will do so it's solid, arrows. And is 0 greater than, hey, this is also true, so we go towards it. So this time we do shade in the little triangle, and then we have a point here at -6, -4. We have a point here at -6, 6, and we have a point right here at -2, 4. So we've graphed, we've stated, and then this one is bounded because we've just have this triangle we are shading in. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel. I'll hopefully see you on the next page of this exam review and hopefully on other videos. Bye. Thanks.